So dependency injection brings us a lot of benefits to the code. It enables us to write very loosely coupled code that is very testable and very easy to use polymorphism and some of these other kinds of things that we always would like to do in code, but somehow we always end up too tightly coupled to do. Well, there's a number of ways we can actually do dependency injection, and we don't just have to rely on dependency injection frameworks. Dependency injection frameworks are good for your larger projects, but if you have a small project or you just have a handful of dependencies, the Web API actually allows you to manage these yourself without pulling in a whole dependency resolution framework just to handle your few dependencies. There are 3 different dependency resolver methodologies we use with the Web API. The lambda expressions is where we basically define all our mappings between interfaces and concrete implementations in a series of lambda expressions that we use in the global.asax. We can also implement this interface, iDependency Resolver, which allows us to isolate our dependency resolution code and allow us to wire it up however we want. This is, by the way, the same way that we usually use to wire up DI frameworks. We're not going to cover DI frameworks specifically right now, but when we talk about implementing iDependency Resolver, that is very much the way you're going to want to go to wire up a DI framework. When we use lambda expressions, this is basically a sort of lightweight take on the service locator pattern. If you've not used the service locator pattern before, basically the pattern is somewhere I've got a list of abstractions, so they're probably interfaces. Interfaces are abstract classes. And then I've got a list of concrete objects that implement those. And so when my application needs an implementation of an interface, it goes to the service locator and says, hey, I need an iRepository. And the service locator finds the iRepository, sees what object is mapped to that, and returns you the object. It's a really kind of lightweight way to do sort of a dependency resolution, dependency injection kind of thing. If we want to use lambda expressions, all we need to overload is setResolver, because instead of using setResolver to point to some kind of dependency injection container or some kind of implementation of dependency resolver that we've written ourselves, we're just going to put lambda expressions in there. The code for this is all in line. Now, this can be a good thing or a bad thing that is largely dictated by the size of your implementation. Inline code for this kind of thing is good if you are mapping, 1 to 5 dependencies. You might stretch it out a little bit if you need to. If your dependency injection needs are just very light, then doing this in line is not that big a deal. However, once you have all this code in line, as you add dependencies to it, it can get really ugly and get really out of hand and very difficult to troubleshoot. So we only want to use lambda expressions in very small implementations. The next way we're going to look at for resolving dependencies is to implement iDependency Resolver. The Web API recognizes the methods that are defined by this interface. These methods are getService and getServices. GetService is used when there is only one available implementation for an abstraction. GetServices is when there are several possible implementations of an abstraction. So, for instance, if I have an interface like iFileWriter, I might have an XML file writer, and I might have a text file writer, and I might have a comma-delimited text file writer that could all implement that. And so I would need getServices to put forward a collection of those possible objects so then my code can select which one it needs. But these are the 2 methods you're going to need to implement when you implement iDependency Resolver. But the good news is if you're okay with that, then it makes your work pretty easy, because in global.asax, all you have to do is set the resolver to the class that you just wrote. This is good for small implementations where you still need some degree of separation. The problem with the lambda expressions is you are tightly coupled to that specific mapping. If instead you implement an iDependency resolver, now you're abstracting that code out, you're putting it in its own area where you can keep track of it nice and tidy, But the other thing is, you may write other dependency resolvers that you need in different circumstances for different runtimes. So I might have a dependency resolver that resolves all my repositories to data access I wrote for SQL Server. But maybe over here, I have a stack of repositories that I've written to go against Oracle. And so depending on the runtime or the service call or some kind of flag in my config file, I may need to swap out dependency resolvers. And so using this technique gives me a whole lot of flexibility where I wire it up without being so heavyweight that I need to bring in a full-fledged dependency injection framework. So it's good for those smaller implementations where it would still help to have more separation and encapsulation than just a bunch of Lambda expressions. Okay, so I want to start taking a look at how you can use Lambda expressions to do some really lightweight dependency resolution. And I want to emphasize this is pretty lightweight. You do not want to use this for big projects, but if you just need to wire up a few dependencies, then this might be your best bet. There's no sense in wiring up a big framework just to resolve a couple of dependencies. So here's how we do this in the web API. It all comes down to this method where I take the global configuration, service resolver, set resolver. And here's where I'm actually going to do my inline resolution. Okay. So within this set resolver is where my Lambda expressions are going to go. So for example, I might do something like, here's the type I'm trying to resolve. So if this is the type I'm trying to resolve, then let's say all of my controllers need a repository. So one thing I might do is something like if the type is a type of controller or a specific controller, or however you want to map this up, then I might do something like return new. Let's say I've got a home controller, and I'll just map this specifically for home controller. And I can say return new home controller and then pass it the repository that it needs. So something like new book repository. Okay. Now this is actually not going to like this very well because home controller actually doesn't take a book repository, but the books controller does. Okay. So we can actually use this to wire up dependencies, or we can say if x equals a type of a particular interface, then return a new concrete instance of that interface. But as you can see, you're going to be doing this with just about every particular type you need. Also, if I need to implement multi-instance, I've got several different implementations, then I'm actually going to need to build a new list of all the possible implementations. So I'm just going to put new list object here. But this code would actually be replaced by you going through and building up a list of potential objects that could satisfy this dependency. Let's see. I'm not closing something quite right yet because it's right. What I have to do here, if I don't find the type, is return null. There you go. All right. It's giving me all code paths does not return a value. Okay. I'm going to get rid of all the red by bringing in the controller's namespace. This is going to come from models. Okay. And now we're set. And if all we had to deal with were the books controller and the repository that it needed, this would be great. But you can see how this is going to turn into a nightmare the more dependencies you have. You know, for 1, 2, maybe even up to 5 or 6, this is not that big a deal. But this is going to get pretty unmanageable once I start moving into, say, a line of business-sized application where I could have many, many services, many, many repositories, and many, many implementations that need to be fulfilled. So instead of doing this for all my dependencies for a slightly larger project, say I've got a project and it's large enough that I don't want to have tons of Lambda expressions all over the place, but it's not so big that I want to bring in a whole dependency injection framework. I still feel like that's overkill for some reason or what have you. Well, one of the things that I can do is actually implement the Depdendency Resolver. So I could come up here, and I'm just going to add a class to the root. You could obviously put it anywhere you wanted. And I'm just going to call this, you can call it whatever you want, Standard Web API Resolver. And I'm going to have it implement the Depdendency Resolver. Let's get the namespace up there. There we go. Okay, and there are 2 methods that we need to implement when we do this. Get a singular service instance for a type, and get a collection of service instances for a type. Now, I want to just mention that if you are going to wire up a dependency injection container, this is pretty much the same thing you're going to do. You're going to take the getService method and you're going to implement that with your DI specific code here. So if I'm using structure map or autofac or whatever, this is where the structure map stuff's going to go, or this is where the unity stuff's going to go. And I'm going to take that service type and use that particular container's methods for resolving that type. Here, we're free to code anything, and we can even code the Lambda expressions that you saw before, or, you know, if we have a map of types, we can use a map of types here. There's all different kinds of things we could do, but this is where you're going to set all that up. Okay, so I might do something here like, you know, if service type is, well, let's do this. Service type is equal to type of iBook repository return new book repository. Else return null, because I can't handle that dependency right now. And I could just do this. Yeah, what's the namespace? I can just do this for every dependency I've got. So you can see this is a little cleaner than the Lambda expressions, and it's nice and encapsulated in its own class. But even so, we're still going to run out of steam pretty quickly here, and I still have to come up with some kind of scheme to return a collection here, or just assume that's never going to happen, and throw a new not implemented exception, or always return null. You could do that, or you could return a new list of object, which is just basically going to be an empty list, so your code that might depend on it isn't going to blow up right away. There's different things you could do here. But the point is that you are using the Depdendency Resolver to define yourself how you want this to go. I can sit here and just define service types and concrete implementations all day. It's very much like the service locator pattern. Now, once I have my mapping ready, let's remember the name of our resolver, then in global.asax, where we put all those lambdas, instead we're going to use the exact same code, service resolver, set resolver, but instead of putting in lambda expressions, we are just going to put in an instance of the resolver we just wrote. Since we implemented the interface, the web API knows exactly what to do with it. Okay? It knows it can call those getService methods, and then it will just execute whatever code we wrote to implement those methods. And that's all it takes. Now, whenever the Web API sees a dependency that it needs to resolve, it'll go to the code we wrote here. And once again, while we're in the neighborhood, if you are using a dependency injection framework and not something you wrote yourself, what you also want to do is create a resolver wrapper around that, and you can just delegate to those methods within these methods as well, and you just hook it up the exact same way.